Okay, circuits, the infamous circuits. This is another very important one where you need to get answers. So even if you create content, you need to get answers because you often use your answers in other questions. So we're normally going to start out with a theory question. In this case, we do as well. Why is there no current through RZ? The trick is the current comes around here and then has a choice. I can either go through zero resistance wire or I can go through a resistor. That is called a short circuit. There is a short circuit with RZ. No current goes through RZ and it all goes through the wire. If we can just check our numbers quickly, the story says that the EMF is 12 and the internal resistance is 0.2. Both of those numbers are on the question. And then here it says when both switches are closed, the ammeter reading is 5.5. So this guy is 5.5 amperes when the both switches are closed. They want you to calculate the resistance of resistor RY, and the resistance of RY, it says here, is twice that of RX. So at the moment we have an EMF number, we have a little r number, and we have an I number. If we have those, we can use the EMF formula. So here I'm just going to use this method because this is what I would have done. And let's see what happens after that. So I don't want to look at this because I didn't teach you this thing, although you can get it from Kevin Maths and Science or whatever it is. I just want to try and delete that one for the moment. So in this formula, we have the 12, we have the 0.2, we have the 5.5, which is the current, so we can work out capital R, which is the total resistance. And you can see here that number goes in the place of R parallel because this resistor theoretically isn't even happening because of the short circuit. So that resistor technically isn't even there. So now they're putting in 2R because you're solving for the resistance, and it said that this one is double that one. So it's R and 2R, and you solve for R and then you double it to get 5.95 for resistor RY. That one is fairly straightforward. I'm not sure we would have known to skip resistor RX, but they do try and tell you here by saying give a reason why there's no current going through RX, then you kind of know that there's no current going through RX, which means you can ignore the resistance of RX. So that one I don't think was too bad, but everyone could have just written this formula and put some of these numbers into that formula and gotten 1 or 2 out of 5. Everyone can do that. Don't get anywhere near the answer, but then just say that RY is equal to 5 or 6 or 7 or something. Because then later on, you can maybe use it again if it suits you. Okay, so RY is done. Then 8.3, they ask you to calculate... Sorry, 8.3 is at the bottom here somewhere. Oh no, I've lost 8.3. Oh, there it is. 8.3 asks you to calculate the power. So, Sherbert. Okay, come on, cover it. Okay, so 8.3 asks you to calculate the power dissipated by Rx. So you need to find the power in this guy over here. Now this is for 4 marks, so this is not just FSA. You have to do a bit more than that. FSA is 3 marks. Anything more than that will be 4 or 5. So it's not just formula substitution answer. But I need to know 2 numbers about this resistor over here, this guy. So what I can do, I have the resistance of this one and the resistance of that one because I worked that out in the previous question. So even if you made up an answer, you would have the resistance of both of these, and you have the current that goes through both of them. You have the resistance of both of them together as well, which you worked out in the previous question. So if you want to work out the voltage in parallel, this voltage, you can use, so that's the one I would use. Where is this now? Hold on, sorry. I'm just gonna, come on Terry. I'm just gonna make another one of these so I can cover that stuff. Okay, so this is the one I would have done. So you can work out the voltage because you've got the current in parallel is 5.5. All the current goes through the parallel part, and the resistance of the parallel part was 1.98. So you can get that the voltage is 10.89 in this voltmeter over here, this one. So you have the voltage in Rx, and you have the resistance of Rx, and now you need to get the power of Rx, which is just going to be V squared over R. But you aren't going to use your brain, you're going to use your formula sheet. So, sorry. So yeah, I would use this one in the middle because you worked out the V and you have the R, so you can work out the power. So you can get from there to there. Well, they worked out 10.9, but so, and then it says here there's a range because it depends on what numbers you used previously. And they say if the 10.9 is already calculated, you can have all 4 of the marks. So for 4 marks, you have to do 2 formula substitution answers. And you should get an answer of around 40 watts. I don't think that question was too bad either. You get given the formulas for power, and you must just sub numbers into them in order to get the mark for the formula. You can't just write random formulas, you need to sub something into it. Okay, now they're saying when both the switches are open, the ammeter reading is 1.3. So now we have a completely different situation, which is maybe going to stress some people. However, the EMF will still be 12, and the little r will still be 0.2. However, the ammeter reading is now 1.3. The resistance of this will still be the same. The resistance of these things will still be the same. But opening the switches has essentially removed Rx and added Rz. So the resistance of Ry will be the same. We don't know what the resistance of Rz is, but we do know what the current is. So, sorry, but this is maybe a bit of an easy question actually, which maybe you'll think so, maybe you won't. But if the switches are open, you can still use the EMF number, and you can still use the little r, and obviously now the current, to get the total resistance. And then the total resistance, you subtract the one that, well, what am I doing? Gosh, man, stupid asshole. Yeah, this is what I wanted. I'm so sorry. So basically, you have the current and you have the resistance. This number here is the resistance of Y that you worked out earlier. So you have this one's I and you have this one's R, so you can work out this one's voltage. Finished. Sorry, then 8.5, you need to work out the resistance of, you need to work out the ammeter reading if you close S2 and you open S1. So now what we're doing, you need to work out the ammeter reading. This is a nice question. You need to work out the ammeter reading if you have all 3 resistors. So we worked out the reading on the voltmeter, which is now again no longer relevant because now we've changed it by adding a resistor again. S1 is open and S2 is closed. So now the circuit looks like this. And we know the resistance of Y, we know the resistance of X, and we don't know the resistance of Z, but we would be able to work it out. The EMF will still be 12, the internal resistance will still be 0.2. So we can always use that EMF formula. So with this EMF formula, and so what they did now, and what I would also do, is you use the numbers that you had in the previous question. So for 8.4, these are the numbers you had for 8.4. And you can use them in order to work out the resistance of Z. Because then, for 8.5, you will then add an extra number that you know. So in order to get the ammeter reading, it would be easier if you had the EMF and the little r and the total resistance, because then in this formula there would only be one thing that you didn't know, which is the I, which is what you want to know. So these numbers here, what they have done is they've used this 1.3 because they used the numbers before switch S was opened. And before switch to S2 was closed. So they used the numbers from 8.4 in order to do this, in order to work out the resistance of RZ. And then once you have the resistance of RZ, you can use the EMF formula again and solve for the current. So you see here we don't know the current and the resistance number is different. The resistance number is the one that we had previously plus the answer to RZ, which we got here. So we have now worked out the current by using the numbers from 8.4 to work out the value of RZ, giving us the answers to RZ, RY, and RX. We have all of those resistances, we have little r, we have the EMF, so therefore we can work out the I.